In this video, I will show you what happens when you bring a charged object near a conducting another conducting object. So here what I have is a thread, a string, and here you can think that I took a piece of foil and I wrapped it, I made it into a sphere, and then I brought a charged rod near this conducting sphere. Now I know that conductors include electrons free to go wherever they want inside that object. Now, because I have excess electrons here, these excess electrons will repel the mobile electrons free to go, free to move in this conductor. And if they are free to go wherever they want, they will try to go, of course, they will move away from these excess negative charges. And away means that they're going to be accumulating on this side of the sphere. Now, if I've got 3 and 3, 7 minus signs on this side of my conductor, this is because they have left on this side, okay, they have left their corresponding positive charges from the other side of the conductor. Remember, this started being electrically neutral, and if you add the plus signs and the minus signs, you do get a zero. But because these excess electrons have pushed away the these mobile electrons, and they pushed them away as far away as possible to the right side of my conducting sphere, I do have some excess positive charges left on their own by themselves on the left side of the sphere. Now, this is charge separation. I have separated some electrons from their positive charges. Now, I want to talk. I said this is charge separation. What we call this this configuration. This is a single one macroscopic. And I'm using the word macroscopic because remember, I took a piece of foil and I made it into a sphere. This is a macroscopic level object. This is something that you can touch, you can move, you can squeeze. So this is one macroscopic level object. This is one macroscopic dipole. And it is a dipole. Remember, dipole means it has two poles, and you can see the two poles, the negative side and the positive side. So this is one macroscopic dipole. Now, I want to think about what kind of forces, what forces are acting now on the sphere. Well, I know that the excess electrons on the rod, I know that they repel this. So I do know that there will be a force from the negatively charged object to the negative side of the sphere. I know that there will be some repulsion going on, and this is the force, say, from the rod on the negative side of the sphere. Now, I do know that these excess electrons are attracting the positive charges on my sphere, but there is an issue. These positive charges are closer to the rod than what the negative charges are, and this is why this force, this attractive force from the rod on the positive side of my sphere, this force is greater, and that's why I have drawn a longer arrow pointing to the left. Now, if you take into account, of course, both of these forces, the repulsive on the negative side of the sphere and the attractive on the positive side of the sphere, you will get a net force. Let's use a slightly different color. You will get a net force that points to the left. So this here, this will be the net force acting on the sphere. And because this points to the left, you should see that this means that there is an attraction. Now, this is a somewhat surprising result because remember, I started having a neutral. I have a neutral conducting sphere. This object is entirely neutral, and I have a negatively charged rod. So I have two objects, and from these two, only one of them is charged and the other one is neutral. But there is an attraction between a neutral object and a charged object, and this is not intuitive. This is surprising. Now, this suggests that you cannot use attraction between two objects in order to decide whether something is charged or not. So, if I give you, let's say I give you a sphere, I give you any object, and I bring a charged object next to it, and I see that this is attracted to my charged object. If I ask you, is this sphere charged or not? You don't know, because even if it is not charged, it will still be attracted to the rod. So you cannot use attraction as an experimental result in order to decide whether an object is charged or not, because attraction happens even when an object is neutral. Now, this is what happens with conductors, and I will make another video where I will show you what happens when you have an insulating sphere.